mainly.
Okay, you want to just give me the equations? Just tell me what they are. I'll probably use
Oh yeah, I can hold on. Let me find the pictures real quick.
yeah, or if it's easier, you can just upload them to here.
Uh, I can just tell you them. I don't, I do that.
Yeah, that's probably easier.
So the
Oh, I
first
see.
one
I
is
I see it now.
okay. Do you want me to still read them out, or do you want to just pull
No,
it
I,
up?
I get it.
Okay.
All right. Secant x minus tan x equals 2 cosine x, and they want you to solve it from x is between 0 and 2 pi. So one revolution around the unit circle.
Yeah.
Solve. Okay, so for these problems that you want to do, they're all kind of a little bit different, right? But
Right.
right away, I'm noticing, let's try to turn them all into sine and cosine.
Okay.
So if we do that, we can see, oh, let's just multiply everything by cosine, right?
Yeah.
Stop me if you're confused. But when I do that here, I get 1 minus sine x equals 2 cosine squared x. And now I can turn cosine squared. If you remember that sine squared plus cosine squared equals 1, the trig identity. So that means cosine
Right.
equals 1 minus sine squared. So I'm gonna substitute that in. And now I have this entire equation written in terms of sine. So distribute that in, 2 minus 2 sine squared x equals sine x 1 minus. So then move everything over to the left. So 2 sine squared x minus sine x minus 1 equals 0. Got it?
Yeah.
And then I can factor that into 2 sine x plus 1 times sine x minus 1. That way
Yeah.
I multiply that and we get negative sine x. Yes, so that works. So that means that sine x equals negative 1/2. Stop me if I'm going too fast. And
No,
sine
you're good.
x equals 1. And so
Yeah.
think of your unit circle. When does sine x equal negative 1/2? Sine is the y coordinate, so it's going to
Uh.
be here, right, and down here.
Yeah.
So it's going to be when this is negative 1/2, which means this is root 3 over 2, or it's positive root 3 over 2, or sorry, negative root 3 over 2, right? And so those two values were pi over 6, negative pi over 6, which is 11 pi over 6, right?
Yeah.
And 7 pi over 6. Did I do that right?
Yeah.
So there are your answers, 7 pi over 6 and 11 pi over 6. And then you can check them. Always you should check them by just plugging those back in. You remember using the store button
Yeah.
in your calculator? Store those for x and then plug those and then plug this equation in this side and this side and make sure that those two things equal each other just to make sure you did it right.
Okay.
Got it?
Yeah.
Questions about how I did that, or is that good?
No, that's good. I was only confused because it was three different like things in the start.
Yeah. Yeah, that's the hard part. Number 4. Is that what you want? Cotangent theta equals root 3 cotangent squared theta.
Yeah.
Okay, well, these are already in terms of cotangent, so you might as well just leave them. Let's set it equal to 0. So there's no reason to convert these things over because now we can just factor out a cotangent theta, and you'll be left with root 3 cotangent theta minus 1. So cotangent theta equals 0, or cotangent theta equals 1 over root 3.
Oh, that's a lot easier than I thought.
See how much easier that was?
Yeah, I thought you were gonna have to like factor it like with
Yeah.
two.
Oh, well, we did factor it, but yeah, not hard. So cotangent theta or tangent theta equals root 3, or tangent is undefined, right?
Yeah.
1 over 0. So those two places, think about where the tangent's undefined. That's where the cosine is equal to 0, and the cosine is equal to 0 here and here. So that's pi over 2 and 3 pi over 2. That's this one. Pi over 2, 3 pi over 2, those two solutions. And the tangent's equal to root 3 when the sine is root 3 over 2. Right?
Yeah.
So that would be, which one is that? Pi over 6, pi over 3?
Yeah. Yeah.
The sine is root 3 over 2, right? What's that?
Mhm. Yeah, so it's I think it should be pi thirds and 4 pi thirds.
Pi over 3, and the other place that that's positive is here.
Quadrant 3.
Yeah, quadrant 2. Quadrant 2.
But isn't it a tangent?
Oh, it is tangent. My fault. Shoot. Yeah, you're right. So thank you very much. So what did you say the other one was?
I
4
think it
pi?
was 4 pi thirds.
Yeah, that's right. 4 pi over 3. You got it.
Okay.
Good job. And again, check them by plugging them in, right?
Yeah.
All right. Next question. Is it C? Is it the one that says C?
Yeah.
Cosecant of tangent inverse of -2. So they just want you to evaluate this, right?
Right.
So what we're doing first is we're looking at the inside here and we're saying, what is this saying? This is the angle whose tangent is -2, and it's the angle between -pi/2 and +pi/2. That's what the tangent inverse means.
Okay.
So what angle is that? Well, think about what that angle is. If the tangent is -2, that means it's not a circle. That means the sine over the cosine, tangent is -2, is -2. Sorry, tangent is opposite over adjacent. So let's just draw this picture out. You know it's got to be in the fourth quadrant. So it's this angle right here, where the opposite is -2 and the adjacent is 1. It's this angle. That's the angle that we're dealing with. Got it? And it's
Yeah.
that's the angle we're dealing with. But now we want the cosecant of that. So the cosecant is equal to the hypotenuse over the opposite, right?
Right.
So I need the hypotenuse here. So that's root 5. Got it? So the
Okay.
hypotenuse is root 5 over the opposite, which is -2. So that's your answer. Root
Got
5, -2. Good?
Yeah.
Number 10.
Yeah.
They even gave you a hint on this one, factor by grouping. So we got tan cosecant plus 2 cosecant plus tan theta plus 1 equals 0. So factor by grouping. So we're going to group these two and take out a 2 cosecant theta. And we're left with the tan theta plus 1 plus 1 times tan theta plus 1. Got it?
Yeah.
Then this factors out of both of them. So it's tan theta plus 1 times what's left over, which is 2 cosecant theta plus 1, and that equals 0. That means that the tangent of theta equals -1, or the cosecant of theta equals -1/2. You good with that?
Yeah.
Skipping a step there. Okay, so when is the tangent -1? That's in the second and fourth quadrant. It's where it's the 45-degree angle, right?
Right.
So that would be 3 pi over 4.
Yeah, and 7 pi over 4.
Perfect. 7 pi over 4. And when is the cosecant negative 1/2, that's when the sine is -2. Does that ever happen?
Not on the unit circle.
It never happens anywhere. You can't have the opposite over the hypotenuse can never be bigger than 1,
Oh yeah.
smaller than -1. So this just does not exist for this one. So that's an extraneous solution. So those
Yeah.
are solutions.
Okay.
Good.
Good.
All right. Next up, man, we're flying through these. This is fun. It's like a competition.
Yeah.
4 cosine to the 4th of theta minus 5 cosine squared theta plus 1 equals 0. So this is a classic one where you're going to say let u equal the cosine of theta squared. And then
Okay.
rewrite this in terms of u. So it's 4u squared minus 5u plus 1 equals 0. Get how I did that?
Yeah.
That's called u substitution. That's the best way. That's the most typical way of writing it. So this would be 4u minus 1 and u minus 1. Does that work? Yeah, that works. Equals 0. So u equals 1/4 or u equals 1. And remember, u was cosine squared.
Squared.
So cosine squared theta equals 1. So that means that the cosine of theta equals plus or minus 1/2. And the cosine of theta equals plus or minus 1. So that
Yeah.
all of the numbers, all of those values, and every quadrant basically. So the cosine is 1 or -1, so that's at 0 and pi. And the cosine of 1/2, cosine is the x coordinate, so that's the pi over 3. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3.
Yeah.
There you go. 6 answers.
Got it.
Good.
Good.
Number 4, tangent of 3x times tan x minus 1 equals 0. So I think what we're going to need here, there has to be probably some formula for tan 3x.
I
Is
don't
there
have a.
is there a tan a plus b formula that you have?
Yeah, I do have that.
I don't remember what that is.
Hold on. 1 second. I have that somewhere.
I'll look it up too. I got it. It's equal to tan. So it's equal to
Tan.
the tan of x plus the tan of 2x all over 1 minus the tan x tan 2x. That's what that is. And
That's
then
tangent double angle.
that's tangent of a plus b. That's
Okay.
tangent of a plus b. Maybe there's a different way to do it, but that's just what I'm thinking we're maybe going to have to do. Let's see. Does that help us simplify anything? How about what's tan what's tan 2x now? Tan 2x. Let me see that formula.
Wait.
Tan 2x, because now now I might have to do this, equals the 2 tan x all over 1 minus tan squared x.
Yeah. The formula I had was tan A plus tan B on the top.
Yeah,
Not
yeah,
tan
but
X plus.
a and b is x and 2x.
Oh, okay. Got you.
Yeah, right. That's what I'm thinking of that as.
Got it.
Maybe there's a formula for tan ax. Is there a formula for tan 3x? Maybe. Let's find out.
Uh,
Maybe there's a formula for tan 3x. If
There
there
might
is,
be.
if there is, I've never seen it. Oh, there is one.
Okay.
I
I
don't
don't
know
have.
that it necessarily helps us, but there is a formula for it. um, okay, why am I being an idiot? I'm so sorry. We don't have to do any of this.
Oh, okay.
I'm so sorry.
No.
I was jumping to try doing stuff fancier than we really need. No, all we need to do is we already have this. This is already that times that equals 0. So just write tan of 3x equals 0. And then tan of x minus 1 equals 0. So tan x
Equals
equals
1.
1. And
Tan
uh,
x equals 0.
so this is where um, yeah, so now you can convert this thing if you want to that other thing that we had. Um, and well, I've got another formula in here, so let's try this. 3 tan x minus tan cubed of x all over 1 minus 3 tan squared of x equals 0. So you don't really have to worry about the denominator. You just have to worry about the numerator when you're setting them equal to 0, because that's how you're going to get your zeros. So is that going to help us? So let's see, factor out of tan x. Tan x 3 minus tan squared x equals 0. So either tan x equals 0 or 3 minus tan squared x equals 0. So that means 3 equals tan squared x, which means tan x equals plus or minus the square root of 3, and tan x equals 0.
Wait, could you explain how you did that again?
Which part?
Uh, this whole part in the red.
Yeah, so when you have a formula like this, the denominator
Uh-huh.
doesn't even matter, because the only way that this fraction is going to equal 0 is if the numerator equals 0.
Okay, that makes sense.
And when you do that, by the way, you just have to make sure when you get your final answers that they don't plug in there and give you an undefined answer in the bottom. Like, make sure that when you plug in these things, you don't get 1 minus 1. In other words, because then it would be undefined, right? 0 over 0 is actually not a solution. So when you have a denominator, you just have to make sure that your answers for the numerator aren't also zeros of the denominator.
Got it. Okay.
Okay. So the square root of 3, tangent of 0. What's the tangent of 0? It's 0, right? Yeah. So 0 works
Yeah.
fine. 0 works fine because 1 minus 0 is 1. And then the tangent, uh, well, if the tangent, I'm sorry, the tangent x equals 0. So the tangent, this is tangent x squared, right? So if you put the square root of 3 in there, it's going to be 3 times 3, it's 9. So no, that's going to be a negative number. So all of these things are legitimate. So now
Got
let's
it.
use those to solve for x. Okay. So
Okay.
x can be, tangent is 1. That's in the first and third quadrant. So that's pi over 4 and 5 pi over 4, right? The
Yeah.
tangent is 0 and at 0 and pi, right? And tangent is plus or minus root 3 at a lot of places. And you're like, just look at your unit circle and find them all. What is that?
It would be pi thirds.
Pi over 3, or is it pi over 6? Pi over 3?
I think it's pi over 3.
Okay, so all the pi thirds. So pi over third, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So I would just make sure by plugging that in to make sure that actually works, but I believe that's true. So the trick was this right here. That was the hard part. How do you know when the tangent of 3x equals 0? trying to think if there's another way you can do it. Oh, here, let's try this way. You could also do it by saying the tangent of u equals 0. And where does the tangent of u equal 0? When u equals pi 0 or when u equals pi,
Yeah.
right? But remember, u was 3x. So this is when 3x equals 0 or when 3x equals pi. And actually, okay, this is even trickier. The 3 there means that the period of that trig function is
2 pi thirds.
yeah, it's pi thirds. So you actually have to go 3 times around the unit circle. So you have to actually do, you kind of have to do all of them. So do u equals negative pi. Might have to do negative pi. Might have to do u equals 2 pi. U equals 3 pi. You got to kind of do all of those, right? So 3x equals negative pi, 3x equals 2 pi, and 3x equals 3 pi. So now let's solve all of these. X equals 0, x equals pi over 3, x equals negative pi over 3 if I need that one, which I don't. X equals 2 pi over 3, x equals 3 pi over 3, which is pi. We got to keep going, don't we?
Yeah.
X equals 4 pi over 3. Keep going. X equals 5 pi over 3. So that's the other way you could have done that problem.
Dang, okay.
Does that make sense? I know I kind of went in a couple different directions, but you could have done it either way. I don't need that negative. Wait, do I need the negative? What do they want the solutions for on that one? I forget. Between 0
0 and 2 pi.
Yeah.
Yeah.
So you just have to keep going around, basically. You have to keep going around the circle until you get past 2 pi, right? If I keep going, if I go to 6 pi, then I would be at 2 pi. But
Right, so that wouldn't work.
I don't need that. Okay. So either way works. You could either do it algebraically like I did by using a different formula like I did right here, like finding a different formula for tangent 3x and then solving that algebraically like I did here, or you can use u substitution and then go that way to do it.